Welcome back, guys and gals. Chapter 7, Section 4 again. First part, we talked about what is trig, and today we're going to answer the question, what are we going to do with it? All right, in our first video, we just looked at the trig ratios, what they are, how to write them. Today, we're actually going to start using them, right? What can we actually do with the trigonometry that we know at this point? So let's take a look at some uses here that we can do. So what we can do, and I can sum it up in one quick line, is that we can do pretty amazing feats of math. All right, and the real answer is real simple. We can find the lengths and angle measures of right triangles without having to use Pythagoras' theorem. With the Pythagorean theorem, remember we had a squared added to b squared is c squared, and we needed at least two of those sides, right? We needed a and b and use those to find c. Problem is, not in every situation are you going to be given two sides of a right triangle. Shoot, you might even be given, let's draw one out here real quick. You might know, say, one extra angle beside that 90 degree and maybe one of the sides. I don't know. If that's the case, you don't have near enough information to use Pythagoras' theorem to figure out anything more than that. So that's where trig will come in and to save the day. We've got more than enough information here actually to solve the triangle. To solve the triangle means to find all angles and all sides. So trig's going to help us be able to do that. So let's dig into it. Let's use trig and we'll find missing sides first. So we'll start with that. So take a look. I got a little word problem here for us to work through, see what we can figure out. It says Dakota is standing on the ground 97 yards away from the base of a cliff. So let's draw Dakota in. So Dakota, I don't know, something like that. There we go. From the base of cliff, using a theodolite, which is a fun tool that you can use to measure distances without actually measuring the distance itself, so a form of indirect measurement. He noted that the angle formed by the ground to the line of sight, so in other words, as Dakota is looking at this, his line of sight is looking up here to the cliff's edge. He noticed that that was going to be 56 degrees. So we need to find the height of the cliff to the nearest whole yard. So let's take a look. Dakota's standing here. So again, remember our trig ratios. We had SO, CA, TOA. All right. So let's look at what we have and which trig ratio, either sine, cosine, or tangent, is going to provide us the best opportunity to solve this situation. So from this angle, I've got a side that is opposite. All right. So that makes either tangent or sine an option since they both have opposites. And then I've got the side that is adjacent. Well, that one lands squarely on tangent's shoulder. So let's write it out. So the tangent of 56 degrees, because that's the point of view that we're viewing this from. So the tangent of 56 degrees is equal to the opposite side, so in this case, x, over our adjacent side, in this case, 97. Awesome. So what we need to do is we need to solve this equation to see what x is. Now, before we get into that, let's talk about this. When we're looking at tangent of 56, you need to treat this tangent of 56 kind of like a variable for the time being. It's a number, it's a variable, however you want to view it, but it's an entity all of its own. So in this case, if I'm going to get rid of the 97, I've got to multiply both sides by that. So the way I'll write that is not, let me do it over here. I'm not going to take, for example, the tangent of 56 and then multiply by 97 this way. I am not going to multiply those two numbers. That's not how it works. What I'm going to do is write my 97 here. This means 97 multiplied by tangent of 56. All right, do not, I repeat, do not try to multiply the 97 and the 56. That's not how that operates. So here we are. So this is what we've got. So x, our distance from the bottom to the top of our cliff here, is 97 multiplied by the tangent of 56. Now, what we'll use to find that is a calculator. All right, I don't know all those fun tangents off the top of my head. Now, remember, before you do any sort of trig work, mode, if I can hit my finger in the right spot, make certain that your calculator is measuring degrees. If you're in radians, you're not going to get an answer that we're looking for. Maybe correct, but not in degrees. We're going to only work in degrees this year. So make sure that's selected. If you need to do it, do it. So what we type in is 97. You can put the multiplication sign in there if you want. You don't have to. I'm going to put it in there since I've already typed it. So 97 tangent 56. Remember, go ahead and close those parentheses just to get in the habit of doing it. We were asked to round to the nearest whole yard. So in this case, 144 would be our answer. So x is approximately 144 yards. So this is one way for us to use trig. We can use it to find missing sides of right triangles that, quite frankly, in this case would be impossible to do with Pythagoras' theorem. It's just not going to work. We don't have enough information. But with trig, we have more than enough information. As a matter of fact, if we wanted, we could find this missing angle. We could find this other missing side, the hypotenuse, and basically know all that we need to using nothing but trig. All right, let's try something else. Maybe if I can get my page to turn. Here we go. What about finding missing angles? All right. So notice in this case, I've got a triangle that's been gridded out for us. We're asked to find A, so angle A here. So I'm going to kind of mark that. And we know where all the locations are. So let's find all of the sides first. So what I'm going to do real quick is I'm going to redraw my triangle over here. A, C, and then B. I'm just going to do that because the grid, I don't know, it's messing with my mind and I don't want to have to deal with all those little boxes. Now, notice this side, AB, is just 1, 2, 3, 4, 5 boxes long. So I'm going to write that in, 5 boxes. All right. Now, let's figure out where this right angle is. Well, notice the slope of C to B is down to over 1, right? Down to over 1. So that's a -2 slope. Our slope here for AC is up 1 over 2. So those are opposite reciprocals. So that means my right angle is here. So I'm going to go ahead and pin that in. Let's find our distances. So our distance here from C to B, let's see, we'll take the square root of, the difference from 5 to 6 is 1, so 1 squared. Added onto, let's see, the difference from 4 to 2 is 2, so 2 squared. So that is 1 and 4. So in other words, that distance is the square root of 5. I'm going to leave that number as it is, the square root of 5. Okay, I repeat, I am not going to mess with that any further. I want to keep nice, perfect answers, or exact answers rather. I do not want to round at this stage of the game. All right, I'm going to go ahead and find this other side. Technically, I don't have to have it, but I do want to know all my sides in this case, and I'll show you why in a second. So let's find this out. So again, square root of changes in x, let's see, that's 4 squared, and then changes in y's, that is 2 squared. So that is 16 and 4. So this is the square root of 20. Remember, 20 is not a perfect square number, but we can simplify this one. In this case, we could break it down into 4 and 5. Square root of 4 is 2, and of course the square root of 5 is not perfect, so we'll just write it there. It is 5. That way I've got nice, exact answers. Now remember, A is the angle that we are unsure about. Now that I have all 3 angles, it really doesn't matter what trig function I use to figure it out. I have all the information that I need. So I'm going to use sine just because I can. If you'd like to use either cosine or tangent, feel free, but I'm going to use sine just because it happens to be listed first. So I'm going to write it out this way. I'm going to write it out, the sine of A is equal. Remember, I need the opposite over the hypotenuse. So the opposite for A is square root 5. So we'll just write that down, square root 5 over the hypotenuse. In this case, the hypotenuse is 5. So we'll write it like that. So what I want to know is angle A, not the sine of angle A. So I've got to get rid of this. So let's ignore that for just a second. Let's try something simple. Suppose I had 5 times x equals 10. All right. If we were to solve that equation, notice that this is a multiplication issue. I would undo that, right? I would use what's called an inverse. I would use the inverse of multiplication, in this case division, to help me figure out that x is 2. We're going to do the same thing here. We're going to use the inverse of sine. And here's how we do that. If I take the inverse of sine on this side, obviously sine would go away, and that would just leave a. The way we write the inverse of sine is like this. We'll write sine, and then it looks like a -1 as the exponent. All right. We'll put parentheses in, and then we'll go ahead and rewrite this fraction, the square root of 5 over 5. Now, how do you type that into your calculator? Well, that's a good question. Take a look. Here's what you'll do. Notice how you have sine, cosine, and tangent on your calculator. You have a second function above it. Notice it says sine, and then it has that -1. So I'm going to hit second sine. That gives me the inverse of sine. That's how we read that. So we'll have the inverse sine. Notice we've got the parentheses. Let's type this in. Second square root 5. Notice we have open parentheses, so we need to do close. That way it's just square root 5 divided by 5. And then get in the habit, close parentheses. That way we don't have anything else that we're going to accidentally tack in there. And in this case, we find that A, and what were we asked to round to? Oh, goodness, they didn't say. We'll round to the nearest tenth, let's say. So we could say that the measure of angle A is approximately 26.6 degrees. All right, if we were asked to round to the tenths position. If we were asked to round to the nearest whole, then we would just say 27 degrees. But that gives us a way of doing that. Now, notice I picked cosine. Let's switch out real quick. Let me show you that it doesn't matter what we use. Any of these can work. Let's try cosine this go around. So we'll do cosine of A equals, now remember cosine is adjacent, so adjacent to A is 5, or excuse me, 2 radical 5. And then the hypotenuse is 5. All right. So we'll do the same thing we did here. We use the inverse of sine to get what we needed. Here we're going to use the inverse of cosine. So the way that looks is A equals the inverse of cosine of 2 radical 5 over 5. So then when we type that into our calculators, here's what that would look like. We'll do second, this is cosine, so inverse of cosine, and then we'll do 2 times the square root of 5, close parentheses, make sure you get in the habit of doing that, divided by 5, close parentheses. Cool. And what do you know? We get the exact same answer as before, roughly 26.6 degrees. So it doesn't matter which sides we take, so long as we use the correct ratio for that given trig function. And we'll get a good answer either way. So in this case, technically we only needed 2 sides to do it, but I wanted to find all 3 just to show it doesn't matter which ones we use, so long as we use the correct ratio with the correct sides, we'll get a good answer. All right. So let's try a few. I've got just a handful of examples here for us to work through, and let's see what we can do. So in this case, we're asked to find x and y, and we're rounding to the hundred, or excuse me, not tens, or yes, tens place. I can read tens place, not hundreds. So let's get started. I know that what we've got at this point is a median. Notice it goes from the vertex to the middle of the other side. Notice it is a right triangle, so technically we could use Pythagorean theorem here. So if I take 36 squared and subtract 24 squared and take my square root, I should be able to find that overall distance. Let's do that. So we'll take the square root of 36 squared and subtract from that 24 squared. 24 squared. I can't get my calculator to work right. There we go. And we get approximately 26.83, et cetera, et cetera, et cetera. If we want an exact answer, it's the square root of 720. And for today's purposes, I'm going to keep that square root of 720 for now, just because that is going to give me a slightly more accurate answer. So let's hold on to that. So I need to find x. So let's see if we can do that. And by the way, I'm going to use this in just a second to help me find y. Like, why in the world did you do that? I'll show you. Let's do x first. X, I've got more than enough information. I've got the 24 and the 36. So let's see what sign ratio that is. So let's write this out. So, TOA. In this case, I've got opposite and hypotenuse. So opposite and hypotenuse is sine. So the sine of x is equal to the opposite, in this case 24, over 36. Right? Remember, we're going to use inverse sine in this case. If we're finding angles, it's the inverse of the sine. So x is equal to the inverse sine of 24 over 36. And notice I didn't bother simplifying that fraction. Since I'm going to use it in my work, there's really no point. So let's do that real quick. And again, I'll show you how to type it in again in case you aren't sure. We'll do second sine, so that's our inverse sine, of 24 over 36. And we get roughly, let's see, we're rounding to the tens position, so 41.8. So the measure of angle X, we'll say, is approximately 41.8 degrees. Cool. Well, now that I know that, let's focus on the smaller right triangle. So that side is the square root of 720 divided by 2. All right, because remember the whole thing was the square root of 720. Half of it is just square root of 720 over 2. So let's use that. So I've got y that I'm looking at in this case. I've got opposite over adjacent. Opposite over adjacent is a tangent issue. So let's do that. So tangent of angle y is equal to opposite. So in this case, the square root of 720 over 2 over 24. Yikes. Off screen there. But it's a compound fraction. Crazy. So let's do this real quick. Let's go ahead and figure this out. So the square root of 720, make sure you close your parentheses there. Close your parentheses there. Divided by 2. That gives us the numerator. And then we're going to divide by 24. Awesome. So I've got y equals the inverse tangent of roughly, we'll say, 0.5590. Now here's what I don't want you to do. Do not use just that number. No. Keep that number. Watch what you can do. Hit second inverse tangent, and then hit second. And the button you want to push is this negative sign. Notice above it says ANS. That stands for answer. So it's going to grab that answer and put it in here so I'm not having to type it all, and it'll keep it exact for me. Awesome. So the measure of angle Y is approximately 29.2 degrees. Right. Cool. Let's try another one. For 57, again, trying to find X and Y, we're finding side lengths. I'm going to focus on this left-hand triangle to start. We got 55 degrees, 12, and X. So from 55, I've got opposite over adjacent. Well, that's a tangent issue. So let's write that out. The tangent of 55 is equal to the opposite, so in this case, X, over adjacent, so in this case, 12. So let's work through that. We just got to multiply both sides by 12. So 12 multiplied by the tangent of 55 is X. Cool. Let's type that in. 12 tangent of 55. And we find that X, I guess the side length there is not equal, approximately 17.1 whatever units they happen to be. We couldn't care less at this point. All right, let's try it again. This time, now that we know that, okay, we're going to do it with this other triangle. So we've got 47. We've got this fun number, and then y. So let's write it out. So I've got opposite and hypotenuse this time. So that's a sine issue. So the sine of 47 is equal to opposite. So what we just got, and here's what I'm going to write. Instead of writing 17.1, because that's a rounded answer, I'm going to write this down. I'm going to write, since that opposite side is technically 12 times the tangent of 55. That way I don't get any weird rounding issues here, because that is the value of X. We'll put that in, and then over y. All right. Well, in this case, that's going to work pretty easy. We'll multiply both sides by y. So y multiplied by the sine of 47 is equal to 12 multiplied by the tangent of 55. All right. I'm going to divide both sides by tangent of 47. So here we go. Y equals 12 times the tangent of 55 over the sine of 47. Now you may be thinking, how in the world do I enter that into my calculator, Mr. Lamar? Well, remember, that is the tangent, or 12 times tangent 55. I didn't get rid of it, so I'm going to hold on to that. So immediately I'm going to hit divide, and notice the calculator goes ahead and takes that answer and plugs it in, so I don't have to type it in again. Now I can just keep going. So we'll divide it by the sine of 47. So that's a pretty simple, easy way to do it. And in this case, we find that y's distance is approximately, 23.4, again, whatever units we're talking about, inches, miles, it really doesn't matter. All right? So that's what we're going to be doing with trig. We're going to do things with trig that we simply could not do with Pythagoras' theorem. It's going to help us find not only angle measures that we don't know, which Pythagoras' theorem couldn't do anyway, but it's also going to help us figure out side measurements that I simply couldn't do because we don't have enough information. If you have questions or concerns, or if you're having issues with your calculator, please bring those with you to class and we'll get them all cleared up. I promise you, trig is not half as hard as it seems. All right, have a good day, guys and gals.